Okay guys, now let's see the next chapter, the most important chapter in entire chemistry, periodicity. Periodicity is going to explain many properties. That's math chapter ku neenga use panikalam. For example, organically use agum electronegativity, and based on that electron pull aguma illaya. Okay, so this is an important chapter. Take your time and read it over and over again. There are many periodic properties you are going to see. The most important of all, okay, is Z effective nuclear charge. Followed by Z effective, you would see atomic radii, ionization energy, electron gain enthalpy, okay, and to an extent electronegativity. These are arbitrary values. Now in the anju illama there are many things that come in NEET many times. Okay. Some of them are predicting your acidity or basicity, your thermal stability of compounds, density, particularly exceptions, and valency. Valency normally neenga periodic table paathe sollalam, but what I am referring to here is there is something else specifically called inert pair effect. We will see this later. Okay. These are the properties predominantly we are going to see. Obviously there are other properties too. Solubilities, particularly S block they will talk about solubility of carbonates, halides and your hydroxides. The ellame solubility, lattice energy, all this will come under periodicity. Now I will try to summarize everything in one chapter. Okay. Now we will go one by one. Okay. In general, இது எல்லாமே உங்களுக்கு கொஸ்டினா வரும். அதுல கொஸ்டினா வராதது அப்படின்னா Z effective. Straightforward கொஸ்டினா வராது. But Z effective determines most of the properties. Z effective, basically what it means is the force with which the nucleus pulls an electron or holds on to its own electron. Effective nuclear charge, அதுதான் Z effective. In generally, Z effective is proportional to the number of protons, okay, and it is inversely proportional to size. We will see why this is going to be. Now let's take a crude visualization of an atom. Okay, I am just going to be drawing shells. Okay, this is shell 1 or principal quantum number n equals 1, n equals 2, n equals 3, so on and so forth. Now what we are going to do is we are going to look into, let's say, a particular electron. Okay, this electron is actually not going away, it is orbiting this particular area. Shapes are different, but let's call it an area. Orbiting a particular area. இதை விட்டு வெளியில போக மாட்டேங்குது. Number one reason is because it's being attracted to the positively charged nucleus. Protons are present, neutrons don't have any charge, although they contribute to gravity. Okay, now we are going to look into what is the charge or the force that this electron is going to feel because of this nucleus. Now straightforward என்ன சொல்லலாம், நியூக்ளியஸ்ல வந்து உங்களுக்கு பாசிட்டிவ் சார்ஜ் அதிகமாக இந்த எலக்ட்ரானோட அஃபினிட்டி இதுக்கு அதிகமாக இருக்கும் நியூக்ளியஸோட. So we can say my Z effective equals to Z. Z is crudely number of protons. Now obviously straightforward இப்படி இருந்தா we don't need a symbol called Z effective. I can just say the effective nuclear charge is Z itself, number of protons. But that's not only that. இந்த எலக்ட்ரான் இந்த நியூக்ளியஸ் கூட அட்ராக்ட் ஆகுது, but not 100%. What will happen is these are inner shells. அதில் இருக்கிற எலக்ட்ரான்லாம் வந்து இதை ரிப்பெல் பண்ணும். Number one. Number two, they will shield the nuclear charge. So இந்த எலக்ட்ரான் ஃபீல் பண்ண போற சார்ஜ் எதிர்பார்த்ததோட கம்மியா இருக்கும், because the inner cores shield it. Now there is a formula to find out Slater's rule. We will worry about that later. At this point, theory side, இதுக்கு எனக்கு வேணும்ன்ற charge or எதிர்பார்த்த charge is going to be decreased by what is called shielding. Either you can use a symbol S or sigma depending on books, doesn't really matter. So this stands for shielding. Okay, so basically Z effective is a sum total of the positive force or the force inwards because of number of protons, subtracting from it the amount of shielding. Shielding அதிகமாக Z effective கம்மியாகும். Okay, now let's look into it. How is this useful for us? When you take a periodic table, let's assume that this is where we start. We can look into two different trends as we go from left to right in a periodic table along a period and top to bottom along a group. இங்க லெஃப்ட்ல இருந்து ரைட்ல போறீங்கன்னா ஒரே பீரியட்ல போறீங்கன்னு அர்த்தம். ஒரே பீரியட்ல போகும்போது what happens is the number of proton increases. So Z effective should increase, but shielding also increases. As you keep going down, electron keep going to the right, electrons add பண்ண shielding அதிகமாகும். வேற orbital shield பண்ணும். S orbital, D orbital, P orbital, so on and so forth. But Slater's rule, if you calculate, you will actually know protons அதிகமாகிற அளவுக்கு shielding அதிகமாகாது. So எனக்கு இது அதிகமாகுது, இதுவும் அதிகமாகுது, but equal அதிகமாகல. இதுதான் அதிகமாக increase ஆகுது. So net sum என்ன இருக்கும்? Left line right ல போக this is increasing more than this. So the sum of this is going to be negative. This is negative, but say sum of this is going to be increasing as I go from left to right. So Z effective increases as effective nuclear charge is going to increase. Okay, when I go from top to bottom, what happens? Top to bottom போகும்போது number of proton increase ஆகும். Shell add ஆயிட்டே போது number of proton increase ஆகுது. அதே equivalent proportionல shielding increase ஆகும். So for every one unit Z goes up, same amount S goes up. So நீங்க கீழே போக Z S ஒரே மாதிரி increase ஆகிறதுனால minus பண்ண literally the effect is 0. So Z effective or Z effective as I keep going down is approximately same. So along a period Z effective is going to be same. Sorry, correction. Along a group Z effective is going to be same. Along a period Z effective is going to increase. Now just knowing that is going to help us with other periodic properties. Okay. Now where all can it be useful? Z effective. Now let's look into it. Let's take an atom, let's say M. Let's look into its ions. M minus, M plus, the corresponding anion and cation. Now how can Z effective be different for them? Now this is the reference Z effective. Now when I go to M plus, what I have done is one electron remove பண்ணிட்டேன். Then I am talking about some other electron here. So electron கம்மி ஆயிடுச்சு, protons அதே மாதிரி தான் இருக்கு. So when you look into it, or let me put it this way, electron to proton ratio. Okay. Now electron to proton ratio, electron கம்மி ஆயிட்டே வருது, ஆனா proton அதிகமா இருக்கு. So imagine this, you have an atom, சென்டர்ல வந்து உங்களுக்கு proton அதே அமௌண்டா இருக்கு, வெளியில இருக்கிற electron கம்மியாக let's say 10 protons attracting 10 electrons is standard. Okay. Now 10 protons attracting 9 electrons is going to be even more efficient. So நல்லா attract பண்ணும். So the Z effective in this one is going to be higher. Now let's go to M minus. அதே 10 protons தான் இருக்கும், மைனஸ்னா ஒரு எலக்ட்ரான் அதிகம். So 10 electronsக்கு பதிலா 11 electrons இருக்க போகுது. So let's look at an arbitrary number. Let's say electron to proton is 10 by 10. Electron to proton is 9 by 10. Electron to proton is 11 by 10. So where do you think the protons can hold on to the electrons very well? Obviously 10 பேர் வந்து 9 பேர் பிடிச்சு வைக்கணும்னா much easier, whereas 10 of them holding on to 11 is not going to be efficient. So Z effective is going to be higher in a cation, followed by the neutral atom, followed by the anion. So we can extrapolate it as Z effective, a neutral atom, a cation is going to be higher and anion is going to be smaller. So now I can extrapolate it even further and say M2 plus M2 minus. We can extrapolate it. Let's take an example. let's say for example sodium, it has electrons by proton 11 by 11. So I'm going to look into Na2 plus, Na plus, Na, Na minus, Na2 minus. So the electrons are going to be 9, protons is 11, proton is 11 in all of them. Now electrons are 10, 11, 12, 13. Obviously 11 protons positively charged can attract 9 negatively charged electrons much more efficiently. So Z effective in this particular setup is higher than 11 protons attracting 10 electrons compared to our neutral atom 11 protons attracting 11 electrons compared to the corresponding anions. So in general, cations have a higher Z effective, anions have a smaller Z effective, neutral atom right in the middle. This particular property is going to be useful for you. இப்படியே கொஸ்டின் கேட்க மாட்டாங்க, but based on this you can tell your ionization energy, electron gain enthalpy. They can ask based on Z effective. Okay, again Z effective is basically a given electron, how it's going to be attracted to the core protons. Now that we understood Z effective, we will look into the ionic radius. Now questions will come straight forward from ionic radii. Ionic radii, generally உங்களுக்கு radius னு கேட்டாங்கன்னா you need to know what type of radii you are talking about. There are few types of radii. Covalent radii, normally most elements க்கு இதை தான் யூஸ் பண்ணுவோம். Metallic radii for metals, solid state ல இருந்து வரும். And then van der Waals radii for inert gases. Okay, so now when I say radius, I am going to be referring to covalent radii. And the atom neutral எடுத்தீங்கன்னா அதுக்கு covalent radii, அதை நீங்க ion எடுத்தா ionic radii னு மாறும். Now when you look into a radius, what you are looking at is in a given compound, let's say a covalent compound, A is attached to B and it forms a covalent bond. How do I say the radius of A is? Normally we can even go to a simple one, a diatomic molecule AA, nitrogen mari N2. Okay, now when I take this, they can measure the bond length from the center of one atom to the center of the another atom. So this is the bond length. So my radii is going to be half of the bond length, somewhere here. I am not touching these spheres, so generally neenga varayanuna, this is the right way of drawing it. Just for simplicity I drew like this. This is how it's going to be. So if this is our bond length, half of this is going to be a radii. So this is called a covalent radii. Now what happens when you have metals? Metals ku covalent bonds irukadhu, they will have metallic bonds. So let's say for example you have sodium. You will see this later in solid state. Let's say sodium occupies the corners and maybe the face center. I am just doing one face center. All the face centers are occupied. Now how they would take it is, we will see the formulas later in solid state. They will know the value of this phase diagonal. Phase diagonal is equal to radius of one sodium, 2 radius of one sodium and radius of another sodium. So phase diagonal equals 4 radii. Based on that they can tell you. This is called metallic radii. But the most important thing you want to know is van der Waals radii. For example, let's take neon. Neon is inert gas, so it is not going to form a diatomic molecule. So neon பக்கத்துல வர போறதே இல்லை உங்களுக்கு. They will stay at a distance. The electron cloud on this one, this atom is going to repel the electron cloud on the other neon. So they will stay at a distance. So distanceல இருக்கும்போது இந்த மாதிரி கனெக்ட் பண்ணலனா நம்மளால bond length கண்டுபிடிக்க முடியாது, because there is no bond. It's just force of attraction. So how this will be is, you can visualize this like a peanut, வேர்க்கடலை. it will look like that. Now when you look into it, what you can do is, you can take the center of one neon and center of another neon, and this is not called bond length, this is interatomic distance. Most cases it is bond length. In inert gases, it's just interatomic distance. They are attracted to each other because any two bodies attract each other in the universe. Similarly, they are repelled each other because of the negative charge of the valence electron and negative charge of the valence electron of these two. So they cannot come any closer, they cannot go any far. So they will vibrate around a certain amount of area. So in the distance நீங்க பாத்தீங்கன்னா interatomic distance சொல்லலாம். So இதுல பாதி எடுத்தீங்கன்னா, okay, half of interatomic distance is here radii. Now this looks similar. இதுவும் interatomic distance மாதிரி தான் இருக்கு இது. The difference is they will come closer in a covalent radii, whereas in a van der Waals radii they don't come that close. So because of this, what will happen is, நீங்க measure பண்ண போற van der Waals radii of any atom is always greater than the covalent radii. Again, we are going to do the same thing for all periodic properties. What happens for a particular periodic property when I go from left to right along a period, on top to bottom along a group? When I go from left to right, my Z effective increase. Last lecture la pathom. Z effective increase agudhu appadina, let's take for example this. Now let's take a periodic table. When I go from left to right, what is common when I go from left to right? Principal quantum numbers or the shell. Shell common ah irukana indha shell la nama pesrom. So இந்த ஷெல்லை பற்றியே நம்ம பேசும்போது லெஃப்ட்லேருந்து ரைட்டில் போகும்போது உள்ள சப்ஷெல் SPD மாறதான் போகுது. Now when I go from left to right in a same shell, number of proton increases, Z effective increases. So வெளியில் இருக்கிற எலக்ட்ரான் வந்து attracted more towards the central core. அப்போ என்ன ஆகும்? சைஸ் shrink ஆகும், அட்ராக்ட் ஆக. So because Z effective increases, the radii decreases as you go from left to right. So when you take any given period, we start with group 1, group 2, group 3 to 12 in a D block, and then 13, 14, 15, 16, 17, 18 is your P block. Okay. Now what happens is, when you go from left to right, group 1 will have the largest radii, followed by group 2, followed by, we will omit the D block for now, we will jump into P block, group 13, 14, 15, 16, 17 and 18. I put 18 as the largest. Left line right la போகும்போது இறங்கிட்டே போணும். But 18 is a inert gas. You don't measure the radius same as this one. இவங்களுக்கு measure பண்ற மாதிரியே நீங்க radius measure பண்ண போறது இல்ல. இதெல்லாம் covalent radii, அது van der Waals radii. So van der Waals radii is higher. So an inert gas in a given period will have the largest radius. Not exactly largest, most cases group 1 will be higher, let's not worry about it. General trend உங்களுக்கு இதான் கொடுப்பாங்க, இல்லைன்னா இங்கே ஏதாவது கொடுப்பாங்க. So as you go from left to right, the radius decreases. You want to remember that. When you go from top to bottom, Z effective is almost a constant. But what happens when you go from top to bottom? I'm adding shell after shell, onion mari. Shell add panna, the distance between the nucleus and the outermost electron increases. So radii increases. Again, when you go from left to right, Z effective increases, consequence radius decreases. Top to bottom, Z effective constant nu சொல்றனால radius constant nu சொல்லக்கூடாது. Z effective constant, so அது ஒரு variable factor கிடையாது. Radius increases because even though the Z effective is not changing, my radius increases because I am adding shells, layer by layer, onion mari போட்டுட்டே போறோம். So radius increases. So now what all they can give you is, multiple type of problems will come in NEET, even IIT mains. என்ன மாதிரி ப்ராப்ளம்லாம் வரலன்னா, ஒரு செட் ஆஃப் பீரியட்லேருந்து 4 எலமெண்ட்டை கொடுத்து உங்களுக்கு ரேடியஸ் அரேஞ்ச் பண்ண சொல்லலாம். இல்லைன்னா ஒரு குரூப்பில் கொடுத்துட்டு உங்களுக்கு ரேடியஸ் கேட்கலாம். S block, P block, fluorine, chlorine, bromine, iodine, all those. Obviously iodine is bigger than bromine, bromine is bigger than chlorine, chlorine is bigger than fluorine. இது ஒன்று கேட்கலாம். இன்னொன்று என்ன கேட்கலாம் அப்படின்னா, radius of anion, cation and neutral atom. In general, you can always say radii is always going to be a cation is smaller than neutral atom, smaller than anion. Obviously, yes. இப்போ நம்ம ஒரு ஆட்டம் எடுத்துக்கிறோம், அதான் நியூட்ரல் ஆட்டம், அது சென்டரில் இருக்கு. நான் இன்னும் எலக்ட்ரானை போட்டால் ஆனியனா மாறும். இன்னும் எலக்ட்ரான் போட அவுட்டர் மோஸ்ட் ஷெல்ல வந்து எலக்ட்ரான் ரிப்பல்ஷன் அதிகமாகுது. ஆனால் அதுக்கு ஈக்குவலாக நான் புரோட்டானை இன்க்ரீஸ் பண்ணலை. ஸோ பிகாஸ் தே ரிப்பல் ஈச் அதர், தே வாண்ட் மோர் ஸ்பேஸ். ஸோ கொஞ்சம் பெருசாகும். கேட்டையான் பார்த்தீங்கன்னா எலக்ட்ரானை நான் ரிமூவ் பண்ணுறேன், அப்போது ரிப்பல்ஷன் கம்மியாகுது. புரோட்டான்ஸ் அதே மாதிரி இருக்கிறதுனால அட்ராக்ஷன் அதிகமாகனா உள்ள வரும். Now this trend is exactly opposite to previous lecture. Z effective opposite இருக்கும். But that explains it. Z effective அதிகமான radius கம்மியாகுது. Z effective is highest for a cation. So radius is smallest for a cation. Now we will use the same example like our Z effective. The radius of sodium species. Sodium 2 plus will have a smaller radius than sodium plus, then sodium minus, sodium 2 minus. Okay, this is simple. What they will give you more precisely in NEET is actually not the same element in variable states. They will give you isoelectronic species. Isoelectronic species means variable atoms in different charges, they will have the same number of electrons. So now let's take for example F minus or let's even take Na plus, Mg2 plus, Al3 plus. Okay, now let's write our electron to proton ratio. Number of proton, when you take fluorine, it is going to be 9, sodium is 11, magnesium is 12, aluminum is 13. Number of electrons, normally fluorine 9 proton 9 electron இருந்திருக்கணும், ஒன்று ஆட் பண்ணுறேன் 10. சோடியமில் 11 proton 11 electron இருந்திருக்கணும், ஒன்று ரிமூவ் பண்ணியிருக்கேன் 10. மெக்னீசியமில் 12 protons, so 12 electrons minus 2 electrons gives it 10. Aluminum has atomic number of 13, 13 protons, 13 electrons, aluminum 3 plus na 3 electron remove பண்ணிட்டேன் 10. So now when you see the number of electrons, they are isoelectronic, ஒரே number of electrons, but they are not isoprotonic. So nuclear charge வேற மாதிரி இருக்கும் உங்களுக்கு. Now when you look at it, there is only 10 electrons. So there are 4 different scenarios. எல்லாத்துலயுமே 10 electron தான் இருக்கு. Now which will have the largest size? Look at the number of protons. Where the protons can hold on to the electrons very well. 13 பேர் 10 பேரை பிடிச்சு வைக்கிறது ஈஸி சைஸ்ல, 9 பேர் 10 பேரை பிடிச்சு வைக்கிறது கஷ்டம். So obviously it's not efficient in fluorine minus, as efficient as aluminum 3 plus. So size பார்த்தீங்கன்னா this is going to be extremely efficient. 13 protons can hold on to 10 electrons, so size சின்னதா இருக்கும் compared to Mg2 plus, which is compared to sodium. This is going to have a smaller size. Sodium plus is going to have a larger size, but not compared to fluorine minus. Fluorine minus is going to have even larger size. Now specifically I have not brought 10 by 10. 10 by 10 is going to be your neon. This comes under van der Waals radii, so adana inge kondu vara virumbala. We'll worry about that later, but just a covalent radii of different species. They will always give you same period, same group, same atom, or most common in NEET and IIT is same number of electrons but different number of proton, called isoelectronic species. Now we have seen Z effective first periodic property, followed by that we saw atomic radius, covalent radii, van der Waals radii. Now we are going to go into an important periodic trend. Most of the time this comes as a question in NEET. Ionization energy. School la paathirpeenga. Couple of things we will clarify. What is ionization energy? Definition most of you will say. Basically the amount of energy I need to put to remove an electron. Now extremely important one you need to know is the species has to be in an isolated gaseous atom. Okay, gaseous solid or liquid it has to be isolated gaseous, meaning N2 la irundhu neenga edukradhu ionization energy kediyadhu, ena isolated kediyadhu. N2 ndradhu rendu nitrogen irukku, N ah irukanum, okay, or oxygen by itself, not O2. So isolated atom in a gaseous state. So now when I remove an electron, okay, why do I have to put in energy? Why it cannot come out just by itself, or why it cannot release energy? Now this goes back to Z effective. What did we say Z effective was? Let's say, assume these are the shells. This is an electron. This electron is attracted to the nucleus, and we saw Z effective is Z minus shielding. Now in the electron is attracted to the nucleus, force of attraction. When two things attract each other, okay, this is like bond forming. When they attract aachina, energy liberate agum, or energy is released outside. So if two of them are attracted to each other, energy is released outside. I have to remove that electron, meaning in the attraction na odaikanum. This attraction is releasing energy. I am doing opposite. I am breaking this attraction, so I have to put in energy. So ionization energy is always going to be an endothermic process, meaning நம்ம energy போட்டாகணும் அதுக்கு, because this is just like bond breaking. நம்ம energy போட்டா தான் உடைக்க முடியும். I have to overcome this attraction. So this is always going to be an endothermic process. Now I can remove an electron from an isolated gaseous atom, or I can remove an electron from an isolated gaseous ion as well. When you remove the first electron from a neutral atom, you call that IE1. When you remove from a monocation, you call it IE2 and IE3, so on and so forth. Couple of things you want to know is, as I go from M to M plus, what happens to my Z effective? We saw previously, protons marala, electron mattum dhaan mari irukku. So as I keep going into more and more cationic, my Z effective increases. Appo Z effective adhigamaga pull adhigama irukum. So I can say my ionization energy is going to be proportional to Z effective. What about size? ஒரே ஒரு குரூப்ல நீங்க போறீங்கன்னா மேலே இருந்து கீழே போறீங்க அப்படின்னா அப்ப சைஸ் இன்க்ரீஸ் ஆயிட்டே போகுது. அப்போ வெளியில இருக்கிற எலக்ட்ரான் is far away from the nucleus, so it's easy to be removed. So as you keep going down, size increases, ionization energy decreases. So I can say ionization is inversely proportional to size. Let's see how these two play into effect. Now when I take M to M plus to M2 plus, what happens to Z effective? Increases. Or opposite la paakalam, what happens to size? Decreases. Z effective increase ana ionization increase agum, illana size decrease ana ionization increase agum. So I can extrapolate and say this: IE1 is less than IE2, less than IE3, so on and so forth. This is a universal truth, no exceptions whatsoever. Imagine this way: you have some money, your friend wants to borrow it, கடன் கேட்குறாங்க யாராவது வந்து, நீங்கள் கொடுப்பீங்க. Now once you have given, கொஞ்சம் கொடுத்ததுக்கப்புறம் திருப்பி வந்து கேட்டாங்கன்னா you might give, ஆனால் கொடுக்கறதுக்கு ஹெசிடென்ட்டாக இருப்பீங்க, முன்ன அளவுக்கு தாராள மனசு இருக்காது. If you they keep asking from you, you keep giving, your tendency to give decreases. போக போக நீங்கள் கொடுக்கறது கஷ்டமாக இருக்கும் உங்ககிட்ட வாங்குறது. So that is what is ionization energy. So that's a very good, pretty good analogy. Okay, so this by itself, IE1, IE2, IE3. Now anytime they give interatomic species, you can use Z effective, like our previous one. F minus, Na plus, Mg2 plus, Al3 plus. Guess who has the highest Z effective? Obviously aluminum. ஏன்னா 3 plus இருக்கு. 3 plus means I have lost 3 electrons. என்கிட்ட ஏற்கனவே நீங்க வாங்கிட்டீங்க, நான் இனிமேட்ல இருந்து கொடுக்க விரும்பல. So this will have much higher ionization energy or Z effective compared to F minus. Size போன ஸ்லைட்ல பார்த்தோம். Size is this way. Z effective is opposite So in the trend la paathalum it tells me that ionization energy is going to be this way. Alright. Okay, so this is a trend in ionization energy among isoelectronic species. Now what happens as a periodic trend? From top to bottom, this is group, this is period. When you go from left to right, what happens to Z effective? Increases. Radius decreases. Here radius increases. Z effective is constant. Okay, so when I go from top to bottom in a group, radius increases. Radius perusaga electron edukadhu easy aite pogodhu. So my ionization energy will decrease as I go down in the group. This is okay, no problem. When you go from left to right, now when you go from left to right, electronic configuration மாறப்போகுது. ஒரு குரூப் எடுத்தீங்கன்னா electronic configuration ஒரே மாதிரி தான் இருக்கும். It's not a variable. When you go from left to right, electronic configuration changes. Carbon is going to be different than nitrogen, which is going to be different than oxygen. So electronic configuration will play a role, Z effective will play a role. Generally Z effective வச்சு மட்டும் நம்ம சொல்லணும்னா என்ன சொல்லலாம்? Leftல இருந்து rightல போனா Z effective increase ஆகுது. Ionization energy should increase linearly. It increases but not linearly because of electronic configuration. Now let's take second period. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So I have 2s1, 2s2, 2s2, 2p1, 2s2, 2p2, 2s2, 2p3, 2s2, 2p4, 2s2, 2p5 and finally 2s2, 2p6. Okay, now let's see how easy it is for me to remove an electron. Okay, now when you take hydrogen, let's start that as a reference molecule. Hydrogen or electron remove pannanum and konja kashtam irukku. I put in some amount of energy. Now helium pona, helium is fully filled orbital, so obviously going to be higher. Okay, now going to lithium, it's a next period na size perusagum. So we are over here, lithium ko drop agudhu. Now we are going to look into the trend. Lithium is 2s1. By removing the electron, this becomes 2s0. So this is actually 1s2, 2s1 going down to 1s2, meaning completely filled. So I would be happy going there. So lithium obviously will have a lower ionization energy. Now when I go to beryllium, beryllium has 1s2, 2s2. Will lose the electron easily? Obviously not. Two reasons. One, beryllium is 2s2, completely filled s orbital. Okay, s orbital completely filled. Stability because of that is actually very less, but still nevertheless completely filled. Second thing, ஒரு electron lose பண்றதுனால நான் என்ன ஃபார்ம் பண்ண போறேன்? 1s2 2s2 னு இருக்குது, 1s2 2s1 னா மாற போகுது. That's not an inert gas configuration. So there is no incentive for me to lose an electron. So beryllium will have a high electron ionization energy higher than lithium. Now when I go to boron, what happened when I go to beryllium to boron? My Z effective will increase. Left to right periodic increase ஆக போகுது. Z effective is increased. அப்ப ionization energy அதிகமா இருக்கணும், ஆனா இங்க கம்மியா இருக்கு. That's because boron is 1s2, 2s2, 2p1. Now if I remove an electron, I am going to be removing this electron. So this is what I found. This is from what used to be a normal orbital, I have a completely filled orbital. So I am happy losing it. So hence boron has a lower ionization energy than beryllium. Beryllium lose பண்றதுனால stability வரப்போறதில்ல, ஆனா boron lose பண்றதுனால half filled ஆ வருது. So beryllium is okay. When I go to carbon, okay, I am going from 2s2 2p2 goes to 2s2 2p1. Now do I gain anything by that? Not really. எனக்கு ஒன்றும் பெருசாக மாற போகிறதில்ல இதனால. I am not completely filled. So I am not really willing to give. My Z effective is higher than my boron. So hence it is higher than boron. It's actually higher than beryllium as well. Okay. Now going to nitrogen. 2s2 2p2. Now will nitrogen like to go to 2s2 2p2? Not really. எதனாலனா ரெண்டு ரீசன். ஒன்று 2s2 2p2ன்றது ஸ்டேபிள் கான்ஃபிகரேஷன் கிடையாது. More importantly 2s2 2p3ல இருக்கிறதுனா I am having half filled orbital. குவாண்டம் நம்பர்ஸ்லேயே பார்த்தோம் half filled அப்படின்னா எனக்கு வந்து எக்ஸ்சேஞ்ச் எனர்ஜி அதிகம் and also symmetry is there. Why would I lose that? So I really don't want to give up my electron. So nitrogen will have a higher ionization energy. Now going to oxygen. Oxygen has 2s2 2p4 going to 2s2 2p3. Oxygen has a higher Z effective compared to nitrogen. No doubt about that. Z effective அதிகமா இருக்கு. ஆனாலும் 2s2 2p4 is stable கிடையாது. Whereas 2s2 2p3 is half filled, just like nitrogen atom configuration. So I am loving to go there. So because I am loving to go there, I will lose the electron much easier than what my nitrogen does. So even though Z effective oxygen அதிகமா இருந்தாலும் ionization energy nitrogen ஓட கம்மியா இருக்கும். Because I am going to go into a half filled orbital. When you take fluorine, just like our boron to carbon, there is no incentive. Similarly, oxygen and fluorine பார்த்தீங்கன்னா no incentive. 2p5 ன்றது 2p4 போறதுனால ஒரு சேஞ்ச் வர போறது இல்ல எனக்கு. But my Z effective is higher. So why would I lose electron easily? I don't want to. My size is very small. I am holding on to my electrons very well. Why would I lose that electron? கண்டிப்பா அந்த electron ஈஸியா தராது. So fluorine is higher than oxygen. It is also much higher than nitrogen because of the difference in Z effective. Okay, and then last is neon. Neon is perfectly happy. Inert gas configuration, octet, lot of exchange energy, and also my symmetry is there. Why would I lose all that to go into something that is not all that stable? So I will not give you. So this is going to have a really high ionization energy. Now when you look into helium and neon, they have the highest in the corresponding period, but helium is higher than neon. That's because when you go from a top to bottom in a period, ionization energy decreases because radii increases. Now when you go from neon to sodium, the case is exactly similar to helium to lithium. Sodium loves to lose an electron, so it can become neon configuration, so the ionization energy is low. Then magnesium has 3s2, just like a beryllium has 2s2, fully filled, doesn't want to lose. Aluminum has 1s2, 2s2, 2p6, 3s2, 3p1. I love to lose electron. So நீங்க பாத்தீங்கன்னா ஹீலியம்லேருந்து lithium drop பண்ணுது. Lithium to neon form one period, second period. Okay. Lithium to neon மாதிரியே தான் sodium to argon. It will follow the same trend. And another thing that you can see here is, look at it for any given group. Doesn't matter which group you are talking about, the trend will fall. You can take anything you want. This will fall. Carbon, silicon, boron, aluminum. That's because when you go down a group, ionization energy decreases. So the trend is going to follow this way. Now a couple of things you want to know here, important ones. What is the element with the highest ionization energy? You want to remember this. In a given period, what is the atom with the highest ionization energy? First period helium, second period neon, third period argon. Meaning இருக்கிறதுல highest ionization energy helium. In a given period, highest ionization energy is going to be your inert gases. Given group which will have the highest ionization energy, the higher it is in the group, because of this is the group, the higher it is in the group, it is going to have the highest ionization energy. So in general, what all can we say? Helium has the highest. What will have the lowest? In a given group, group 1 has the lowest. Okay, ஒரு period எடுத்துக்கிட்டீங்கன்னா group 1 தான் கம்மியா இருக்கும். Okay, now you can also look into what is the element that has the lowest among all. அப்போ group 1 தான் ஒரு பீரியட்ல கம்மியா இருக்குன்னா, அந்த பீரியட்ல கீழே போக போக ionization energy கம்மியா இருந்துச்சுன்னா group 1ல தான் இருக்கிறதுல கம்மியா இருக்கும். So when you go to group 1, you're going to have lithium, sodium, potassium, rubidium, cesium, francium. Francium does not exist easily because of extremely low half-life. Only francium compounds exist, francium doesn't exist. So francium you omit pannitingana, when you go down the series, ionization energy decreases. And among the period, group 1 has the lowest. Cesium is the one that has the lowest ionization energy among all stable atoms. Highest is helium, lowest is cesium. Okay. Okay, so now when you take a period, who has the highest ionization energy? Group 18, inert gas, followed by group 17, followed by group not 16, 15, followed by 18, 17, 15, 16, 14, 14, then you have your 13 here. That's not what we want. I'm going to ignore my D block for now. So up to 14 I'm okay. Then I have my 13. Before 13 I have my group 2. Then 13, then group 1. Ignoring D block, this is the order you're going to follow. So my group 1 has the lowest in a given period. Sorry, given group again. Along a group, going down or going above, in general, your 2p will have a higher than 3p, than 4p, than 5p. What I mean by this is, your neon has higher than argon, argon has higher than krypton, higher than xenon, or fluorine higher than chlorine, higher than bromine, higher than iodine, or your oxygen higher than sulphur, higher than selenium, higher than tellurium. Okay, so this is how ionization energy is going to play a factor. Okay, now let's go into the next periodic property. We just saw ionization energy. Now we are going to see electron gain enthalpy. For the most part, they are exact opposite of each other. Not always, they are exact opposite of each other. Okay, so now what is ionization energy? The amount of energy that you have to put to remove an electron from an isolated gaseous atom. This is opposite. Now, the amount of energy required is opposite. That ionization energy is always endothermic. This is not the case. So what I am going to do is, I am going to say generally the amount of energy change, okay, exo amount of energy change associated when an isolated gaseous atom or an ion accepts an electron. Okay. Now, when you look at elements, most of them, one electron they allow the electron, so energy is going to be released. So for most of them, energy is released, it's going to be exothermic. There are exceptions, we are going to see pretty soon. Exceptions irukkumbodhu adu endothermic irukkalam. But there are a couple of things you want to know. Again, electron accept panna varapora energy change. First electron gain enthalpy அப்படினா ஒரு electron போடுறீங்க. Second na 2 electron. Third electron gain enthalpy na 3 electron. Now first electron gain enthalpy வந்து endovaவும் இருக்கலாம், exovaவும் இருக்கலாம். Depending on the case, most of the time exo. But universal truth, electron gain enthalpy 2 and above, this is always going to be endo, meaning energy போடணும். Very simply, நீங்க ஒரு நியூக்ளியஸ் இருக்கு, நீங்க ஒரு எலக்ட்ரான் போட்டுட்டீங்க. இப்போ ரெண்டாவது எலக்ட்ரான் போடும்போது எலக்ட்ரான் ரிப்பல்ஷன் அதிகமாக இருக்கும். So you have to spend energy to overcome the repulsion. Spending energy is endothermic. So second electron gain enthalpy and third and so on is always going to be endothermic. And in terms of endothermic, your EGE2 is less than EGE3 less than EGE4, meaning நான் செகண்ட் எலக்ட்ரான் போடுறதுக்கு எவ்வளோ எனர்ஜி தேவையோ அதோட அதிகமாக தேர்ட் எலக்ட்ரான் தேவை, அதோட அதிகமாக ஃபோர்த் எலக்ட்ரான் தேவை. பிகாஸ் எலக்ட்ரான் repulsion is high. So obviously this is how the trend is going to be, electron gain enthalpy. Now electron gain enthalpy can also be for a not just a neutral atom or an anion, it can also be for a cation. M plus ஒரு cation இருக்கு gaseous state. நான் அதை M லேருந்து கொண்டு வரலாம். So this is IE1. Now what I can do is I can make it go to the neutral atom. This is minus electron, this is plus electron. So M has become M plus, ionization energy 1. M plus can go back to M, electron gain enthalpy. So whatever the process you are doing the exact opposite process. So whatever the energy associated with this, okay, will be exactly opposite over here. Okay, we will look into the trends later. இதை நம்ம வந்து செகண்டுக்கு தேர்டுக்கு அப்ளை பண்ண முடியாது. ஏன்னா ஃபர்ஸ்ட்டுக்கு பாருங்களேன், எம்லேருந்து எம் ப்ளஸ் வந்து ionization energy is always endothermic. இது எண்டோனா ரிவர்ஸில் போகுது எக்ஸோ. இப்போ எம் ப்ளஸ்லேருந்து எம் டூ ப்ளஸ் போகிறீங்கன்னா எண்டோ, அப்போ எம் டூ ப்ளஸ்லேருந்து எம் ப்ளஸ் போகிறீங்கன்னா என்னவா இருக்கும் அப்படின்னு பார்க்கும்போது there are some exceptions. At least this is simple. Now let's go into what happens as a periodic property. You cannot do ionization energy மாதிரி இதுக்கு you cannot do electron gain enthalpy along a period, along a group. It's going to vary a little. Not only Z effective, again also electronic configuration along a period. When you take along a group, as you keep going down, what happens to size? Size increases. Size increase ஆக ஆக உங்களுக்கு என்ன ஆகும்? எலக்ட்ரான் வந்து it's added to outermost shell. But outermost shell is farther and farther away. தள்ளி தள்ளி போக போக இந்த எலக்ட்ரானை வந்து இந்த நியூக்ளியஸ் அட்ராக்ட் பண்ண முடியாது எஃபிஷியண்டா. ஸோ அப்போ இந்த புல் நிறைய இல்லை அப்படின்னா எலக்ட்ரானை போடுறது கஷ்டம். So what will happen? Electron gain enthalpy, the amount of energy released, it will be lower. So as you go down the period, electron gain enthalpy decreases. This is general trend. This is a break in trend la irukum, but in general it decreases. Now let's see how this plays into a factor. Let's look into hydrogen. Hydrogen is where we are supposed to be, wherever this reference is. Now looking into helium. Hydrogen, okay, first before I go into it, I want to explain the graph. When you look at it, ionization energy பார்க்கும்போது நம்ம ஆக்சிஸ் வந்து பெருசாக பார்க்கல இதில், ஏன்னா எல்லாமே பாசிட்டிவாக இருந்தது. இதில் வந்து ஃபர்ஸ்ட் எலக்ட்ரான் கெயின் என்தால்பி பாசிட்டிவாகவும் இருக்கலாம், நெகட்டிவாகவும் இருக்கலாம். நான் ரிவர்ஸ் ஆக்சிஸாக போடுறேன் பிகாஸ் இட்ஸ் ஈஸியர் டு அண்டர்ஸ்டாண்ட். நெகட்டிவ் ஆக்சிஸ் மீனிங் ஹவு மச் எனர்ஜி இஸ் கிவன் அவுட். எனர்ஜி இஸ் கிவன் அவுட் when you accept an electron easily. அப்போ எலக்ட்ரான் உங்களுக்கு பிடிக்கும் அப்படின்னா எனர்ஜி இஸ் கிவன் அவுட். ஸோ எனிதிங் above 0 loves electron, anything below 0 does not want an electron. Okay. So here I have to put energy to overcome the repulsion. Here I don't have to put energy, they give me energy. Okay. So this is a negative axis. Negative is good. Exothermic. இது எல்லாமே endothermic. Exo is good because energy is released. In chemistry that means stability. Now hydrogen wants an electron. Why? There's one proton, one electron. It can take one more electron of opposite spin, become like helium, inert gas configuration. So I'm going to release energy. When I go to helium, why do I want an electron? I'm inert gas. So now do I have to break my inert gas configuration? Not really. So எனக்கு அதை மீறணும்னு அவசியம் இல்லை, ஃபோர்ஸ் பண்ணா மீறலாம். Hence I put energy. So helium has a positive electron gain enthalpy. Now going into lithium, lithium has one electron, 1s2 2s1. ஒரு எலக்ட்ரான் கிடைச்சதுன்னா 2s2 ஆ மாறும். Beryllium configuration, fully filled orbital. So I am happy. I am going to release energy. I have higher, but not as high as hydrogen. இதுக்கு fully filled மட்டும் தான் கிடைக்குது 2s2, whereas hydrogenக்கு inert gas configuration கிடைக்குது. So hydrogen will release more. Now when you take lithium to beryllium, an important exception, beryllium is fully filled 2s2. So now I have to put energy or electron into a 2p orbital. I really don't want that because I have fully filled. அதோட Z effective அதிகமா இல்லை. Okay, left to right Z effective increases. அப்போ இது left side இருக்கிற element இது. So Z effective அதிகமா இல்லை, fully filled, அதை நான் உடைக்கவும் விரும்பல. So I have to put energy. So beryllium comes under a endothermic process, positive process. இது எல்லாமே பாசிட்டிவா இருக்கும். Okay, beryllium is an important exception you want to remember. Now going from beryllium to boron. Boron has one electron in 2p orbital. இன்னொரு electron போடலாம். Okay, I love my electron, so I'm going to accept it, but not that much. ஏன்னா போரான்ல ஒரு எலக்ட்ரான் போடுறதுனால என்ன கிடைக்குது? Not really any stability. So it doesn't really release as much energy as hydrogen or lithium. 2s2 2p1 லேருந்து 2s2 2p2 ஆ மாறுது. Carbon is higher because carbon is 2s2 2p2 ஒரு எலக்ட்ரான் போட்டா +1 2s2 2p3 nitrogen configuration half filled. I really love it. எனக்கு அது கிடைக்கிறதுனால எனக்கு stability கிடைக்குது. So I am going to take that electron, release a lot of energy. When you go to nitrogen, exact opposite. I am really happy. I have half filled. Why do I want to break that symmetry? So I don't want that. So somebody has to put energy for me to make me accept an electron. கார்பனோட நைட்ரஜனுக்கு Z effective அதிகமாக இருந்தாலும் இங்கே நீங்கள் சிமெட்ரியும் எலக்ட்ரானிக் கான்ஃபிகரேஷனும் பார்க்கணும். நைட்ரஜன் இஸ் லோவர். Now let's going into oxygen. Oxygen has higher Z effective than nitrogen and then compared to carbon also. So it is going to accept an electron. But does it really want that electron? By accepting it, you become what used to be 2s2 2p4 to 2s2 2p5. Stability அவ்வளோ கிடையாது. அதனால it will accept but not that much. Okay, so it doesn't release as much energy as expected compared to carbon. Carbon Z effective அதிகம்னா நிறைய கொடுத்துக்கணும்னு பார்ப்போம். But you are also coming into another problem. நீங்க லெஃப்ட்ல இருந்து ரைட்ல போக போக சைஸ் சின்னதாயிட்டே போகும். சின்ன சைஸ்ல இன்னும் எலக்ட்ரான் போடுறீங்கன்னா ரிப்பல்ஷன் அதிகமாகும். ஸோ எதிர்பார்த்ததோட கொஞ்சம் எனர்ஜி வந்து ரிப்பல்ஷனை ஓவர் கம் பண்றதுக்கு யூஸ் ஆயிட்டனால எதிர்பார்த்ததோட கம்மியாக தான் எனர்ஜி ரிலீஸ் ஆகும். ஸோ திஸ் இஸ் ஆக்சிஜன். Fluorine is self-explanatory. I have 2s2 2p5 plus one more electron gives me inert gas configuration. I love it. Even though my size is small, fluorine electron போடுறது ரொம்ப கஷ்டம். ஏன்னா சைஸ் சின்னதா இருக்கும். But still it loves it, so it is going to release that much energy. But still not as much as expected. எதனாலனா inter-electronic repulsion. Now going into neon. It is going to be positive because fully filled. So இதே trend தான் ஃபாலோ பண்ண போறோம் உங்களுக்கு. Now the important trend that is going to break is when you look at top to bottom, electron gain enthalpy decreases. இதனால சைஸ் பெருசாக efficiently electron attract பண்ண முடியாது. So lithium ஓட சோடியம்க்கு கம்மி. That's fine. Okay, beryllium and magnesium it's fine. But where the trend changes is from aluminum. So these are second period elements 2p. Aluminum ல இருந்து 3p வரப்போகுது. When you look at aluminum, it is higher than boron. கீழே போக பீரியட்ல எலக்ட்ரான் gain enthalpy டிக்ரீஸ் ஆகணும். ஆனால் போரானோட அலுமினியம்க்கு அதிகமாக இருக்கு, கார்பனோட சிலிக்கானுக்கு அதிகமாக இருக்கு, ஆக்சிஜனோட சல்ஃபருக்கு அதிகமாக இருக்கு, நைட்ரஜனோட பாஸ்பரஸ்க்கு ரொம்பவே அதிகமாக இருக்கு. மோஸ்ட் இம்பார்ட்டன்ட் ஆஃப் ஆல் ஃப்ளோரினோட குளோரினுக்கு அதிகமாக இருக்கு. The reason is because these are actual values, these are okay, this is normal. Abnormal வந்து இதுதான் abnormal. இது எல்லாமே 2p எல்லாமே சைஸ் சின்னதாக இருக்கும். ஸோ நீங்கள் எலக்ட்ரானை போட போறீங்க, ஆனால் சின்ன சைஸ் இருக்கனால எலக்ட்ரான் ரிப்பல்ஷன் அதிகமாகும். இங்கே ஏற்கனவே சின்ன சைஸு, இதில் இன்னொரு எலக்ட்ரான் நீங்கள் போடுறீங்கன்னா ரிப்பல்ஷன் அதிகமாக இருக்கனால யூ ஹாவ் டு ஸ்பெண்ட் சம் எனர்ஜி டு ஓவர் கம் த ரிப்பல்ஷன். ஸ்பெண்ட் மீன்ஸ் வெளியில் வர எனர்ஜியோட கொஞ்சம் கம்மியாக தான் வெளியில் வரும். ஏன்னா ரிப்பல்ஷனுக்காக நான் கொஞ்சம் செலவு பண்ணணும். ஸோ இது எல்லாமே கம்மியாக இருக்கும் 3pயோட. திஸ் இஸ் சம்திங் யூ வாண்ட் டு ரிமெம்பர். A 2p element will have a lower electron gain enthalpy than 3p element. This is extremely important for you to remember. Okay, this is because of the name for that is anomalous behavior. எதிர்பார்த்த மாதிரி இல்லாம வேரிடா இருக்கு behavior. Anomalous behavior of second period elements. You will see this in P block later. But at that time you don't have to study. Periodicity ஒழுங்கா பண்ணீங்கன்னா P block memory கம்மியா இருக்கும். Anomalous behavior of second period. Anomalous behavior of fluorine, your carbon, your oxygen, your sulphur, all this. Now, what are all that you want to remember? Generally 3p க்கு 2p அதிகமா இருக்கும். But I'm not telling you that 2s 3s. 2s 3s எதிர்பார்த்த மாதிரியே 2s is higher than 3s. 1s is higher than 2s, 2s is higher than 3s. But 2p is smaller than 3p. Okay, you want to remember that. Now, when you look at the graph, what has the highest electron gain enthalpy? This will come so many times in NEET. It has come many times. It might come this year also if you are lucky. Chlorine has the highest. So, ஒரு order கொடுக்குறாங்க greater than எது கரெக்டான ஆர்டர்னு கேட்டாங்கன்னா chlorine ரைட்ல இருந்தா ஃபர்ஸ்ட் அதை சூஸ் பண்ணுங்க. பண்ணிட்டு மற்றதும் ட்ரெண்ட் ஃபாலோ பண்ணுங்க. அதை மட்டுமே ஆன்சர் பண்ண முடியாது. But let's say for example there is an order where chlorine is in the middle. Let's say some arbitrary numbers A, B, chlorine, C. Okay, now I know this is wrong. Chlorine தான் இருக்கிறதுலே அதிகம்னா அது இங்க இருக்கவே முடியாது. So that option is wrong. It helps you in identifying this. Boron, carbon, nitrogen, oxygen, fluorine, aluminum, silicon, phosphorus, sulphur, chlorine. Now what you want to know is, all this will have a higher electron gain enthalpy than second period. You want to take it as second period or 2p orbital, doesn't matter, really the same. So all this is going to have higher. How much higher? You want to remember this trend. When it comes to halogens, chlorine is the highest, followed by fluorine, bromine, iodine. This is okay. இங்க இருக்க வேண்டிய fluorine இங்க வந்துருச்சு, fine. But when it comes to oxygen group, sulphur, selenium, tellurium, then oxygen. இங்க இருக்க வேண்டிய ஆக்சிஜன் இந்த குரூப்ல ஒரு ஸ்பேஸ் தள்ளி வந்த மாதிரி இங்க வரல, all the way it drops. Fluorine doesn't drop all the way because அதே ப்ராப்பர்ட்டி தான், anomalous behavior, but still its electronegativity is so high, its Z effective is so high, so it compensates a little and actually takes a second place, whereas in the oxygen group it's all the way there. Nitrogen group, when you take phosphorus, arsenic, antimony, and then nitrogen, so on and so forth. So you want to remember these trends, they come straight forward for you in NEET exam. Okay, now we have seen Z effective in periodic properties, ionization energy, atomic radii, electron gain enthalpy. Now we are going to go into electronegativity. Electronegativity actually is a very small segment. Now basically what it means is, let's take for example two different elements attached to each other. Okay, now when you visualize them as forming a covalent bond, appo rendu electron irukku, that electrons are going to be distributed like this, probability of finding an electron. Now this doesn't really happen. எதனால ரெண்டுத்துக்கும் நடுவுல electron negativity difference இருக்கலாம். What it gives you is, basically one of them can have more electronegative, means electronegativity character வந்து நீங்க என்னன்னு பார்க்கலாம்னா greediness னு பார்க்கலாம், தனக்கு வேணும்னு எடுத்துக்கிறது. அப்ப ஒருத்தங்களுக்கு அது அதிகமா இருந்தா அவங்க வந்து அந்த எலக்ட்ரான் அவங்க பக்கத்துல வச்சுப்பாங்க. That is what in essence electronegativity is, the greediness, or in scientific terms the tendency to attract shared pair of electron. Shared pair na covalent bonds, rendume shared ah irukkum, tendency to attract it towards itself, meaning attract na panadhu thavara full ah eduthukilla covalent is ionic bond ah maaridum. I take the electron and go away, chlorine minus, I give the electron and go away, Na plus, NaCl ionic. Idu covalent bonds la mattum da electronegativity neenga paaka poringa. Now what it means is, if let's assume that A is more electronegative, so it is going to attract the electrons more towards itself. So this is how it looks like. Electron probability is going to be more towards A, not symmetrical. Now we can give symbols for this. A electron எடுத்துக்கிறனால அதுக்கு negative character, greediness. B கொடுக்கிறனால positive character. B full-ஆ கொடுத்து A full-ஆ எடுத்துக்கிட்டா, that is ionic bond. B is giving partially, so that's a delta symbol, partial positive. This is partial negative. Now ionization energy, electron gain enthalpy, இதெல்லாம் வந்து actual numbers. Electron negativity பொறுத்த வரைக்கும் actual numbers கிடையாது, arbitrary values were given, with fluorine being the highest value, 4.0. So I have shown you the values, you don't have to remember the values, you have to know the trend. Okay, so now what all happens? We can say that electronegativity is a tendency to accept the electron or pull the shared pair of electrons towards itself. அப்ப எனக்கு Z effective அதிகமா இருந்தா நான் அந்த எலக்ட்ரானை நல்லா அக்செப்ட் பண்ணலாம். So electronegativity is proportional to my Z effective, or I can say it's inversely proportional to my size. Size சின்னதா இருந்தா நல்லா அக்செப்ட் பண்ணலாம், பெருசா இருந்தா நல்லா அக்செப்ட் பண்ண முடியாது. Okay, now also I can say electronegativity is proportional to my charge, positive charge. Positive charge na ion, cation. என்கிட்ட சார்ஜ் அதிகமாக நான் எலக்ட்ரானை தொலைச்சிருக்கேன், I have lost electrons. So I really want that electron, so I will have a higher electronegativity if I am positively charged, more positive I am, more electronegative I am. Similarly, inversely proportional to negative charge. This is actually going to be useful in organic chemistry later for you. Okay, at this point we are going to look into Z effective and size, that's more than enough. Now when I go from left to right in the periodic table, Z effective increases, size decreases. Appo electronegativity obviously should increase. When I go from top to bottom, my Z effective doesn't change, but my size increases. Size increase ஆக electronegativity கம்மி ஆகணும். So electronegativity decreases. This is a general trend. Let's see whether we can predict it. Now in a given period, அப்ப யாருக்கு அதிகமா இருக்கணும் electronegativity? Ignoring the inert gases. Group 1 ல இருந்து ஆரம்பிச்சு group 17 வரைக்கும் போறீங்கன்னா group 17 க்கு தான் அதிகமா இருக்கணும். Obviously that's the way my values are. Fluorine has the highest. அதே மாதிரி மேலே இருந்து கீழே போகும்போது இறங்க போகுது அப்படின்னா where is going to be in a periodic table the highest electronegative value? Leftல இருந்து ரைட்ல போக போக ஏறுது, மேலே இருந்து கீழே போக போக இறங்குது. அப்ப left corner is going to have the highest values. Where is it going to be the lowest values? Sorry, right corner is going to have the highest electronegative values. Left to bottom is going to have the lowest electronegative values. Now what all you want to know is, take fluorine for example, it's given an arbitrary value of 4. And the 4 ஞாபகம் வச்சுக்கிட்டீங்கன்னா நீங்க லெஃப்ட்ல வர வர -0.5 பண்ணிட்டே வரலாம். 3.5, 3, 2.5, 2, 1.5, 1. It's arbitrary values. This is okay. Now மேல இருந்து கீழே போகும்போது first decrease இங்க வரப்போகுது உங்களுக்கு. ஆனா exact decrease வராது. For example 4 ல இருந்து 3 ஆ மாறுது, 3.5 ல இருந்து 2.5. அப்ப 3 ல இருந்து 2 ஆ மாறணும், மாறல. 1.5 ல இருந்து 1 ஆ மாறணும், மாறல. அப்படி மாறாது. ஏன்னா அப்படி மாறிட்டே போனா இப்போ இது 2 ல இருந்து இது 1 ல இருந்து 0 ல இருந்து மைனஸ், எலக்ட்ரானிட்டி மைனஸ்ல வராது. So it decreases but not periodically. It decreases less and less as you go down. For example take halogen group 4 3 ஆ மாறிச்சு, 3 வந்து 2 ஆ மாறணும், ஆனா 2.8 தான் மாறுது. Okay, as you go down the electronegativity decreases but not by that much. What all you want to know here? Know this trend. Fluorine is the highest among all elements, okay, followed by oxygen, followed by now nitrogen and chlorine are the same, but nitrogen having a higher Z effective will win over chlorine. Okay, then I have my carbon versus sulphur. The same example is going to be here. Carbon is marginally higher than sulphur. Okay, this you can know. Another thing that you want to know is hydrogen is 2.1. So any element that has a higher value of electronegativity than hydrogen, 2.1 க்கு மேலே இருந்தது அப்படின்னா that element bonding with hydrogen will have electron towards itself. Okay, so H plus ஆ போக வாய்ப்பு அதிகம். But if it is less than that, okay, let's say for example this is greater than 2.1. Let's say Z is less than 2.1 than hydrogen. What will happen? Hydrogen will take the electron and go away. So if it goes, here it will go as H plus, here it will go as H minus, hydride. Example, hydrogen with any metal will be in hydride, H minus. Example, lithium aluminum hydride, sodium borohydride. All the hydrides are when hydrogen is attached to something that is less electronegative than itself. Okay. Now this is enough to do electronegativity. This is something where you can only understand more and more by practicing problems. But basic trend has been given to you. Couple of things we also want to know. Electronegativity is proportional to S character of an hybridized orbital. What it means is an sp hybridized orbital will have a higher electronegativity than sp2, than sp3, than sp3d, so on and so forth. Now S character அதிகம் இதில் எதனாலனா ரெண்டு ஆர்பிட்டல் தான் இருக்கு, அதில் வந்து ஒன்று எஸ், அப்போ 50% S character. இது 3 ஆர்பிட்டலில் ஒன்று, 3ல் ஒன்றுனா 33%. sp3 ஒரு S 3p, 4ல் ஒன்றுனா 25%. sp3d 5ல் ஒன்றுனா 20%. S is greedy அப்படிங்க ஞாபகம் வச்சுக்கோங்க. S greedy இருக்கனால S character அதிகமாக electronegativity அதிகமாகும். S character கம்மியாக electronegativity கம்மியாகும். This is going to be useful for you in organic chemistry when you are looking into alkenes, alkynes, nucleophiles, electrophiles. This is going to be useful. At this point just understand this, that's more than enough. Okay guys, now let's go into the next periodic property. We just saw electronegativity. It is going to be useful for this property as well. We are going to look into acidity of compounds. Acidity கேட்கும்போது உங்களுக்கு ரெண்டு type of acids நீங்க பார்க்கணும். ஒன்று அந்த ஹைட்ரஜன் வந்து attached to the atom directly or it is attached to a given atom through oxygen. ஆக்சி ஆசிடாக இருக்கலாம் இல்லை ஹைட்ரிக் ஆசிடாக இருக்கலாம். எதை கொடுத்துருக்காங்கன்றதை பொறுத்து அசிடிட்டி மாறும். ஃபர்ஸ்ட் ஹைட்ரிக் ஆசிட் பார்க்கும்போது the hydrogen is attached directly to the atom. Hydrogen when it is attached directly to the atom, the acidity is always straightforward. It depends on how easily the hydrogen can go. H plus எவ்வளோ ஈஸியாக வரப்போகுதுன்றது. H plus can easily come when that bond can be broken. அப்போ bond length அதிகமாக இருக்க ஈஸியாக உடையும். So acidity is proportional to my bond length. Now I taken an example of fluorine, chlorine, bromine, iodine, halogens along with hydrogen. Hydrogen ஓட size எல்லாத்துலேயுமே ஒன்று தான். But my halogen size increases, bond length increases. Bond length அதிகமாக இருக்க எனக்கு ஈஸியாக acidity bond உடையும், acidity அதிகமாகும். So if this is the order of bond length, then this should be the same order for my acidity as well. Okay, so my HI is stronger acid than HBr, which is stronger than HCl, which is stronger than HF. Now electronegativity which mattum pathina, fluorine is the highest in electronegativity. I will take the electron and send the hydrogen away. HF is strongest acid ah irukano, HI is weak ah irukano. But this is not electronegativity, this is based on bond length. Now people will make mistake, that's why I am reiterating it. HF is a weak acid. இது மூணுமே strong acid. It is going to be useful in ionic equilibrium. இது மூணுத்துக்கும் pH டைரக்டா கண்டுபிடிக்கலாம், இதுக்கு Ka through கண்டுபிடிக்கணும். This has Ka, that is very small, this has very high Ka. Another thing is, based on practice and memory, you will always think HCl is a strong acid. Yes, it is a strong acid. I am not saying it is not. அது strong acid தான், ஆனா அந்த குரூப்பை பார்க்கும்போது HCl ஓட HBr strong, HBr ஓட HI strong. HI is one of the strong acids that you will see. It's used for ether cleavage in organic. Now, where is this useful? Now, will they ask you this in NEET? Sometimes இதை கேட்பாங்க, sometimes இதோட based principle next கேட்பாங்க. Now, I have my fluorine, chlorine, bromine, iodine. Go into one group to the left, oxygen, sulphur, selenium, tellurium. Okay, this is group 17, this is group 16. Group 17 la HI is stronger than HBr. அதே மாதிரி group 16 க்கு we can say the same. Bond length and acidity, both of them are going to follow the same pattern. My HI is greater than HBr. Similarly, H2TE greater than H2SC greater than H2S greater than H2O. Makes sense. H2O வந்து நீங்க amphoteric னு பாக்குறீங்க, ஆனா H2S வந்து equilibrium ல பாக்கும்போது weak acid னு பாப்போம். So what used to be amphoteric has become a weak acid. This becomes, or let's put it this way, water is a weak acid, அதோட strong H2S, அதோட strong H2SC, அதோட strong H2TE. This has come in NEET. If you know this, you can do this. Maybe இந்த வருஷம் இதை கேட்கலாம், or they can do one more. Nitrogen, phosphorus, okay, arsenic, antimony. So அந்த bond length கேட்கலாம், bond length இல்லைனா acidity கேட்கலாம், அதுக்கு ஏற்ற மாதிரி. Okay, now this is the acid strength of anhydric acid. When you go to oxy acids, so now this is where electronegativity is useful. Now ZOH, is this an acid or a base? H plus கொடுத்த acid, OH கொடுத்த base. So that is going to be determined by Z atom. Z ஓட electronegativity அதிகமா இருக்கா கம்மியா இருக்கான்றதை பொறுத்து. Now imagine this way, oxygen is electronegative. I want electrons. I will take it from hydrogen and send hydrogen away. So now, if it does that, this will become ZO minus and H plus. What if my Z is really good in giving electrons than hydrogen? Then what will happen? Z gives electron and goes away and it becomes OH minus. So in one case, ZOH behaves like a base, other case it behaves like an acid. So which case is which will be determined by electronegativity of Z. Z ஓட electronegativity அதிகமா இருந்ததுன்னா Z எலக்ட்ரான் நிறைய கொடுக்காது ஆக்சிஜனுக்கு. Z electronegativity is high, it won't give electron to oxygen. What will happen? Oxygen, it has no choice, take the electron from hydrogen and send the hydrogen away. So electronegativity of Z is high, it is going to behave like an acid. Conversely, if electronegativity of Z is low, what will happen? Z is low compared to hydrogen, like a metal atom. Z electron எல்லாம் கொடுத்துட்டு போயிட போகுது. Oxygen will take electron from Z and go away. Example, NaOH. This will give you Na plus and OH minus. Needless to say, sodium is lower than hydrogen in electronegativity. It gives the electron compared to hydrogen, goes away as Na plus. So it behaves like a base. Here, for example, I can take CH3COOH. Now Z is this. Now we will see organic chemistry later. Hybridization of this carbon is sp2. S character adhigama, electronegativity adhigam. Also this carbon is attached to another oxygen. So electron idella nariya thara mudiyadhu. Tharadanala, what will do oxygen do? It has no other choice. Take the electron from hydrogen and give you acetate ion and H plus. Behaves like an acid. So for an oxy acid, the electronegativity of Z is going to determine whether something is going to behave like an acid or a base. So in general, electronegativity அதிகமாக இருந்தால் உங்களுக்கு என்ன இருக்கும்? ஆசிடாக இருக்கும். electronegativity கம்மியாக இருந்தால் பேஸாக இருக்கும். Now oxy acids எப்படி எடுத்துக்கோங்க? If this is the periodic table, it has a goofy structure in there, S, P, D, and F. But anyways, electronegativity அதிகமாக இருந்ததுன்னா ஆசிடாக பிஹேவ் பண்ண போகுது. அப்போ Z எந்த இடத்துல இருக்கணும்னா இங்கே இருந்தால் oxy acids will be acidic. Makes sense. HNO3, H2SO4, H3PO4, H2CO3. You can keep going. H2SO3. Now when you take this side, electronegativity is low. So this will be basic. Example, LiOH, NaOH, CSOH, barium hydroxide, all these are bases. Even though they form the same category ZOH, depending on where the Z is, it's going to be different. Now, we can also say Z dot electronegativity kammiyaga easy electron tharum. So electronegativity, when you go from top to bottom, electronegativity decreases. And the order நம்ம பார்த்தோம். அப்போ first group எடுத்தீங்கன்னா lithium ஓட sodium க்கு electronegativity கம்மி, sodium ஓட cesium க்கு கம்மி. So electronegativity கீழே போக போக கம்மியாகிறதுனால ஈஸியா எலக்ட்ரானை தரும். So that means you can also say for group 1 I have lithium, sodium, potassium, rubidium, cesium. Your basicity order is going to be lithium hydroxide weaker than sodium hydroxide, weaker, not weak base na solla, weaker sodium hydroxide. Sodium hydroxide நம்ம strong base nu paapom, but that is still weaker than KOH, weaker than RbOH, weaker than cesium hydroxide. Cesium hydroxide is extremely basic. இது group 1. இதே மாதிரி group 2 க்கு நீங்க சொல்லிக்கலாம். Group 2 beryllium hydroxide weaker than magnesium hydroxide, calcium hydroxide, strontium hydroxide, barium hydroxide. Barium hydroxide is one of our strong base. It belongs to group 2. Now it is so much so that இங்கேருந்து நீங்கள் வர basicity கம்மியாகிட்டே வருது. Beryllium hydroxide is actually not just a base, it's amphoteric. ஆசிடாகவும் இருக்கலாம், பேஸாகவும் இருக்கலாம். Okay. Now we'll take a special case, for example, somewhere here. Boron. We'll take an oxy acid of boron, BOH thrice. So this is boron, OH, OH, OH. Now when you see, it's neither acidic nor basic. So looking at ZOH property, it is actually neither acidic nor basic, but you call this as an acid. It's a monobasic acid. That is because of its Lewis property. Adha nama thaniya paapom. At least at this point I know that. Let's say boron aluminum hydroxide. Aluminum hydroxide is amphoteric. Okay, mildly acidic, mildly basic la irukum. But in general you can use this to figure out whether a given oxy acid is either acidic or basic. Okay, now this will take a little bit of practice for you. Only solving examples you will be able to get it faster. But practice this one. ZOH oda electronegativity ungala solla mudiyum appadina you will be able to pull it, and you have to remember this way. A periodic table visualize பண்ண தெரியணும். அதுல ரைட் கார்னர்னா எலக்ட்ரான் நெகட்டிவிட்டி அதிகம், லெஃப்ட் பாட்டம்னா எலக்ட்ரான் நெகட்டிவிட்டி கம்மி. ரைட் கார்னர்னா அயனைசேஷன் எனர்ஜி அதிகம், லெஃப்ட் பாட்டம்னா அயனைசேஷன் எனர்ஜி கம்மி. ரைட் கார்னர் மேல ரைட் டாப் அப்படின்னா அசிடிட்டி ஆஃப் ZOH is high, left bottom basicity of ZOH is high. You can also say this way, what happens to acidity when you keep going down? கீழே போக போக Z ஓட எலக்ட்ரோநெகட்டிவிட்டியை பொறுத்து தான் அசிடிட்டி. எலக்ட்ரோநெகட்டிவிட்டி கம்மியாயிட்டே வருது அப்படின்னா கீழே போக போக அசிடிட்டி கம்மியாயிட்டே வரும் உங்களுக்கு. ஓகே, similarly when I go here basicity கீழே போக போக அதிகமாயிட்டே வரும் உங்களுக்கு, because of electronegativity. Alright, okay.